This is FlappyBoid Chapter 11, Adding Audio. So audio is a pretty huge topic. What we want to learn to do is just add ambient sounds and what are sounds that are triggered by specific entities or events or collisions, that sort of thing. In order for the engine to play audio, it requires something called middleware. However, CRYENGINE is not tied to a specific middleware because it uses this translation layer, the ATL, the audio translation layer. And through that, we support 3 different middlewares that are out on the market. SDL Mixer is the one that we're going to work with today, which is super simple, but doesn't have a ton of features. And we also support the much more full-featured Fmod and WWise. Something like WWise is complex enough to merit many, many hours of courseware, which they already offer. So we're not going to try and reinvent the wheel as far as that goes. What we are going to do is use the audio controls editor to create a library to bring our sounds in and trigger them. So the SDL Mixer will play WAV files, which is one of 2 formats that you should be using to design your sounds. If you're an audio person, I don't need to tell you this, you'll be using .wav or .aiff, which are uncompressed maximum quality formats. However, it would just be way too intensive and demanding on your game to use these uncompressed high quality sounds in the game. So for CRYENGINE, you're going to want to use the .ogg format. And we recommend a 48K sample rate and a 16-bit sample size. And as far as compression goes, we recommend using a quality level 6, which is a 60% compression ratio, which sort of does a nice balance between quality and file size. Once you've created your sound library for your particular game, you're going to want to put them in the project folder, in a folder called Audio, and then inside that folder, you'll have one of 3 folders depending on which middleware you'll use. We're going to use SDL Mixer, so we need a folder called SDL Mixer, and inside that, we'll use a folder called Assets to actually house all of our OGG files. So when you downloaded the FlappyBoid asset from the marketplace, we've already given you a full library of sounds that we designed just for this game. This is one of the things that you copy into the game SDK folder, is this audio folder. So before we even start playing with the sounds, I want to show you audio debugging, and that's something called SDraw Audio Debug. If you type that like any other CVAR and put a question mark after it, you'll see that there are quite a few parameters to it. You can explore these at length later, but what I recommend for now is that you enable these particular pieces of information, ABDFGMV. It sounds like an eye doctor's test. Once you enable the audio debugging information, you're going to see it in the upper left-hand corner of the perspective viewport. It doesn't look like very much now because we have no audio events. But as we start to trigger things, you're going to start to see some useful information in there. The first thing you're going to want to do is open up the Audio Controls Editor, just right here in the Tools menu. This can tend to get pretty big, so you might want to make some good-sized space for it. I'm going to open it up like this. And you'll see that there are a whole bunch of sounds here already. So this is divided into 3 panels. Over here are libraries. Over on the right are the raw audio files. So anything that's in your audio directory is going to show up here automatically. CRYENGINE generates a .cryasset file for every one of them. Here are some of the files that you see that we gave you for FlappyBoid. And in the middle, once we create a trigger and we assign 1 or more audio files to it, then there are a bunch of parameters here that control how the audio sounds are played, for instance, how loudly or where in the 3D image of your headphones. Before we even start creating triggers, we have to switch on our particular middleware that we've decided to use for our game. And that's this CVAR right here, S-Audio Implementation Name. Since SDL Mixer is the middleware that's enabled by default, technically you do not have to do what I'm doing right now, which is saying, hey, go ahead and switch on SDL Mixer as our middleware. If you wanted to switch on Fmod, for example, it would be this, or if you wanted to enable WWise, it would be this. I'm going to go back and enable SDL Mixer. So our first step here is to create a library. And I'm going to right-click in the blank area of this first pane here. And I'm going to say Add Library. And I'm going to call mine Flappy Audio. You can call it anything you like. The Audio Controls Editor has its own Save button. Simply saving the level is not going to save your current audio library. So let's create our first trigger. What we're going to do is create a very simple ambient sound effect for the ocean, because down here at the bottom of our game, 70 meters below the middle of the game at 100 meters, we have the ocean. So let's create a sound for the ocean. And what we'll do is make that sound get louder as Flappy falls downward and it gets softer the further the bird gets away from the ocean and jumps up. So we're going to go back to our audio controls editor. We're going to right click on the Flappy Audio library and we're going to say add trigger. And I'm just going to call this trigger ocean, very simple name. And you can either search in here or you can scroll and eventually alphabetically you'll find this file ocean.ogg. And we can go ahead and drag that into this pane right here. And now we start to see the controls that we have over it. Most fundamentally, of course, is volume. And you'll notice right away that the default is 14 decibels below our maximum. I'm sure you're used to digital audio and 0 is maximum volume. That's to give you some headroom. If you haven't heard that term before, we don't want everything at the loudest possible setting. We want to give room for the very loudest events that might happen in our game, whether they're explosions or whatever. You can certainly change this like you change anything else by dragging it, typing it, or using these arrow keys. For right now, I'm going to leave it at -14. And there's two important parameters that we care about in this particular case. We don't need to fade in or fade out, although we could choose to do that at the very beginning of the game. What we do care about is attenuation. To attenuate means to reduce, to make softer in the case of audio. We don't want the ocean to pan left or right. It's just going to come from below us, so we can disable the panning. But we do want to enable attenuation, and we have to decide what's the farthest away that our bird can get before he won't hear the ocean at all. Well, given that I set the ocean height at 30 meters, in the middle of the game at 100 meters, there's a 70-meter distance right now between the ocean itself and the middle of the game. And if you think back to the boundaries that we placed, they're only about 11 meters above the middle of the game. So we really don't need this to be much more than 80 meters. So I don't know, I'll set it for 85 right now. This is something you can experiment with. We do want this to loop over and over again because it should be on all the time. And that's really it for this particular trigger. It's very simple. I'm going to save before I forget, and you notice the little asterisks disappear just like in Flowgraph. In order to hear this, we actually right-click on it and we say Execute Trigger. And there's our ocean sound. And by the way, to stop it, you can go to another sound here. For instance, here are some sounds for the first-person shooter player to fire a gun. So here's a single shot's reverb, a single shot by itself, and one that's had this looping enabled, so it creates a machine gun effect just by going over and over and over again. Now, any sound that we're going to use as a continuous ambience throughout the game, we also need to make sure we stop when we close the level. So I'm going to create another trigger by, again, right-clicking on my Floppy Audio library. I'm going to call this Game End. And I'm going to drag that same ocean sound into this, but this time the action that I'm going to perform on it is to stop playing it instead of to start playing it, which was the default action that I didn't really point out the first time around. So it's a very simple trigger, but an important one. Let's go ahead and save that library. And now let's actually put the sound into the game. So our gameplay takes place up around here, more specifically kind of in this area, as we move up or down from this 100 meters off the ground position. So what I want to do is position my speaker, which is going to be something called an area box, down here where the water is. So it's as if the sound is actually emanating from the ocean. However, I also want to be able to hear it a bit further away over here when I'm looking at the world through my Game Over camera and I'm looking at my Game Over text. So right now I have these entities fairly far apart, and I may not be able to use the same so-called speaker or area box for both, but we'll try it and then see if we can make some adjustments. So I'm going to go ahead and position one here. And the first thing I want to do is hide the ocean because things are going to be snapping to the terrain. If your terrain is off, make sure it's on now. And it'll just make it easier to sort of put things into place. And I want to create an area box. You can use a box, a sphere, a shape that you make to project your sound. I'm just going to use a simple box. I'm in the create object mode. I'm going to put it somewhere around here. And I'm going to size it. Since it has no mesh, kind of like a camera, I can't use these transform parameters. So I'm going to use these area box parameters to size it at 30 by 30 meters and 1 meter high. I want to put it directly under my Game Over box, so I'm going to use that P pick object trick to snap it to be perfectly centered under the game object box. And I'm going to slide it a bit this way so there's no chance that the camera won't be over it. I guess I could probably slide it even a little bit more this way. something like that. This whole thing is going to act as a speaker. The next thing we need to do is actually add our audio entity, which is going to be the source of our sound. So in create object, audio, in this case, it's just an ambience. It's something that's background noise all the time. So we're going to use audio area ambience, which is a lot harder to say than it is to use. So go ahead and click on that. You get your create object. I'm going to try and put it approximately where this thing is. Now, the truth is that it makes no difference where this audio area ambience object is. We're going to link it to our so-called speaker, so it can be floating around anywhere. I'm just going to leave mine kind of up here. I'm going to turn my ocean back on so I can see what's happening. So you can see that I've got my speaker, which I actually need to move down. Since I want it to imitate the ocean itself, I'm going to float it literally right on the surface of the ocean at 30 meters. And then my audio area ambience object, just to keep it clear what it is, I'll float it a bit above it here at 36. I see it's ended up way back here someplace. So I'm going to use my pick object trick again. P, and then click on area box to center it over there and then just move it a bit above it. Okay, now we're ready to actually link our speaker, our area box, to our jukebox, which is our audio area ambience entity. If I have to say that 3 times fast, I'm doomed. So we're going to click on our area box. We're going to go up here to the very first set of properties, area, and under target tools, we click on pick and then simply click on our audio entity. And now there's this connecting line. So no matter where I move this audio entity to, it's connected to my area box, which means it's going to project a sound through it. We don't hear anything yet because we haven't assigned a sound to the audio entity. So let's go down here to the Lua properties, and we're looking for play trigger. And we want to browse to our ocean sound. And for the first time, we finally hear something. And then, of course, we need to give it a means of stopping the sound on game over. So the stop trigger is going to be our game end. And here's the one tricky part. While Fmod and WYs are very sophisticated and also have extensive licensing fees associated with them, which is one of the reasons I'm not showing them to you, they can pass parameters. But SDL Mixer is very simple. It basically starts and stops sounds, and it can deal with attenuation. But there's one thing that's not completely obvious, which is this RTPC parameter. RTPC is real-time parameter control. And although we can't pass parameters using SDL Mixer, we do need to match this setting to the max distance setting on our sound trigger. So I'm going to go back here to my audio controls editor, back to my ocean trigger, and you see I have my max distance of 85. So I need to actually match that in this setting right here for this to work properly, RTPC distance. You're not going to hear any difference yet, but now if we have our audio debugging on and we start to pull back from our entity, you hear the ocean sound fade away, and you'll see this piece of information right here telling you exactly how far away you are. Let's see if I can zoom in on it for you. And as I move back, when I hit 85 meters, the sound disappears completely. As I move closer, it fades in. Okay, now that we have our sound in place, let's actually shift our camera to where the gameplay area is. And I think you can hear right away that the sound is pretty much gone. So there are a couple of things that I can do here. I can make the sound louder back here on my trigger. I can bring this up, but that's a bit tricky and dangerous because I'm talking about balancing, mixing all of my sounds together. And since this is supposed to be a background sound, I don't want it competing with the more impactful sounds like colliding with the pipe, etc. We could, of course, increase the distance from which it's heard, and that would solve the problem. But what I'm going to do is simply move this sort of game over stuff closer to my main gameplay area. So I'm just going to drag a box around everything, go into full screen view, and just slide it over. Something like this. So it's closer to my main action and hopefully not close enough that my camera field of view sees that last pipe. You can see it's sort of missing that pipe. And now if I go back to my gameplay area, now you can hear it in the background, and it's soft enough where it's sort of background ambience. And as Flappy falls and the camera falls with it, since the sound is attached to the camera, the ocean is going to get louder and louder. And at some point as I go up, if I jump up too far, I won't hear the ocean at all. So it works very smoothly. So let's test this. I'm going to save. We jump and we hear it very softly in the background. We're not going to hear a very dramatic difference if we follow the rise very much to follow the pipe movement. But now I'm going to crash and watch. The second we jump to the game over camera, we're very close to the source of the sound and it gets a lot louder. And as the camera sinks below the ocean, we're getting farther from that area box and it's getting a little softer. However, we'd probably be best off just muting the sound once we sink underwater, or drowning it out with an underwater sound, because the ambience of this isn't really consistent with underwater ambience. There's one more thing that I should be sure to do, which is to actually name these entities. So I'm going to call my area box AB Ocean, and my ambience entity AAA for Audio Area Ambience Ocean as well. And I'm going to go ahead and create a layer for this audio stuff, just so I can keep things nice and organized, and drag all of these entities down there. And I'm going to go ahead and make this the active layer, since I'm going to be doing more with audio. Okay, what I want to do next is deal with a collision sound. I'm pretending our Flappy is some kind of bird. And in fact, I've supplied you with some chicken sounds, which you might find amusing, or you might want to use something of your own. And I've created a sound that's a collision and also this sort of squawk of distress as the Flappy chicken sort of falls down. And I want to trigger that sound when I collide with one of the pipes. So the first thing is I'm going to go back to my audio controls editor, right click on my library, add a new trigger, and I'm going to call it pipe collision. And over here, if you search for the word collision, you'll see a sound I created called pipe collision with squawk. It's a combination of sounds. And I'm going to make this a bit louder. I'm not sure exactly how much it's going to be. I don't need to worry about panning because it's going to come from the same place the camera is. And I don't need to worry about attenuation. I'm going to save my library, go to my flow graph, and specifically I'm going to the section that detects collisions. So I'm already detecting the collision here, and all I need to do is go to a folder I haven't explored yet, which is audio, and grab this trigger node. So the first thing is I have to tell FlowGraph where in 3D space the sound is emanating from, because this is different than an ambience. The sound technically is coming from where the bird collides with the pipe. So you could choose to make it come from the bird. It actually might make sense, since the bird is going to fall down, that sound would get softer as it gets further away. So I'm going to go ahead and select my FlappyBoid, and I'm going to assign that as the entity. So that's sort of my speaker. That is where the sound will be placed in the 3D space. Next, I need to tell it which sound to play, and that's my play trigger. It's going to be my pipe collision. And I want to trigger it on the collision, so I'm just going to drag this same collision detector to the play input of my audio trigger node. I'm going to save, full screen, and test. And I'll jump for a little while, and I'm just going to tell you that before I collide, something surprising is going to happen. We're going to get our collision sound, but we're going to get something unexpected. You can... Sometimes it can be quite a bit worse than that. So if we pulled back to a wider camera like this, what we would see is that when the bird falls, it bounces around and collides many times with these pipes, an unpredictable number of times. And every time that happens, it's triggering this sound to play over and over again. And in fact, it's sort of interrupting or overlapping itself because it's already in the middle of playing. It's a bit of a long sound. So the point is here, in this case, given the kind of sound that I made, I only want this to happen once on the first collision, and then I'm kind of done with it. So I need to create some more logic here before I go and trigger this. And what I want to do is create a game token just to track the number of collisions. So only on the first collision will I actually trigger this. So I'm going to go back to my database, add a new item, and I'm simply going to call it collisions, and it's going to be an integer. It's just a simple counter. So I'm going to start it with int. And before I forget, make it an integer instead of a Boolean. Otherwise, I'll be in big trouble later. Come back to my flow graph. I'm looking for another game token set that I can just borrow and copy. And then I'm just going to change the token that I'm setting to my collision, which I meant to write as collisions. That's okay. And I'm going to initialize its value to 0. Now, back to the collisions here. When this happens, I want to modify that. So I'm going to do game token modify. And I'm going to go ahead and trigger that. And the token that I'm modifying is my collisions, or collision. I want to add a value of 1 to it. And of course, it's an integer. And there we go. So now that I have it modified, I need to look at that value and say, well, if that value equals 1, and only if that value equals 1, go ahead and play this. Otherwise, even though I'm still colliding and still modifying this, do not trigger this again. So I'm going to use math in range. There's more than one way to do this, but this is how I'm going to do it. And I'm going to set both my minimum and my maximum to 1. And if that's true, that it equals 1, then and only then am I going to trigger this node. So I collide. Let's say that for the first time, I add 1 to my collision counter. I ask what the value is. I say, is it equal to 1? If it's true, then I play this trigger. Otherwise, nothing happens anymore on this. Let's test that. I'll collide. And you can see that even though it collided a second time right away from here to here, we only heard that sound once. The next thing that I want to do is create some kind of splashdown sound so that when this game over raft lands in the water, we hear the splash. So what I've created is a combination sound of falling and then splashing. So let's create a trigger for it. Back to my audio controls editor, right click on Flappy Audio, say add trigger. I'm going to call this fall and splash. You search for the word splash here, you'll find a Fallin Splash sound. I don't need panning. I am going to keep attenuation on since I'm initially far from the sound, and then I'm going to jump cameras and move closer to it. If I save this and test, you can hear what it sounds like. So the tricky part about this is by combining those two sounds together, you're locked into a certain timing. So we're going to have to do some experimentation to time the actual splashdown of the game over box with the actual sound of the splash. It might have made more sense if you want to try two separate sounds falling, and then you could put a proximity trigger under the water, kind of right here, where the game over text would hit it, and when it contacted it, you could stop the falling sound and then trigger the splashing sound. So don't forget to save your library. I'm going to go back to my flow graph, and I'm just going to copy this audio trigger since I'm going to make another one of these for my splashdown sound. Point it to my new Fallin Splash trigger. And the only thing is, I know I'm going to need some kind of delay. I just don't know how much. So I'm going to insert a time delay node. I'm going to try 1/10 of a second. However, keep in mind that we already have a delay before we jump cameras here. We have this 1 second delay in our game over section before we jump here. And let's give this a test. You may have already figured out what I missed, which is the trigger is being played back up where the bird is, which is too far away to hear. What I want to do is play it on the game over camera because that's where I am visually. So I'm going to assign that entity. The sound is coming in way too late. So I think what I'm going to do here is actually delay the falling of the raft. I don't want to just sit here on this camera when there's really nothing to look at. So instead of triggering the game over raft to start falling right away, I'm going to delay it the same way that I'm delaying switching to the game over camera. And give that a try again. And I think the timing there is pretty good. The next thing I want to do is create a sound for this final sequence of sinking underwater. So I'm going to add one more trigger. Just call it camera syncing. And if you search here, you'll find syncing.ogg. I don't want to attenuate this because it's going to be wherever the camera is. I also don't need to pan it. Not entirely sure how loud it's going to be, but let's give that a try. Save my library, go back to flow graph. And again, the tricky thing here is timing. So I'm going to copy this audio trigger here because it's already mapped to the correct camera. Change my trigger to my syncing. And I know I'm going to need a delay. So after all this business is done, this kind of starts. One thing I could consider is putting this over here because I have this action that begins here, that begins to move the camera down. And very shortly after this camera movement begins and it actually sinks underwater, I want that sinking sound to begin. So I may need some kind of additional delay But for now, I'm going to actually paste that node here. And after this delay I already have, I'm going to go ahead and trigger the syncing sound. And actually, it's not too bad. Next, let's create a simple sound that the bird makes every time you press the jump key, as if it was sort of straining to fly upward. So I'm going to right-click on my library again, create another trigger, and just call it squawk. If you search for the word squawk here, you'll find a bunch of them at different pitches here. I don't know, I'll try the medium one. And I want to make this fairly prominent. I don't need to attenuate it, nor do I need to pan it. I'm going to save. And then back in my flow graph where I have the jump going on, all I'm going to do is use another audio trigger node. And then again on the Flappy cam is where I want to actually play the sound. Sound I want to play is my squawk. And I'm going to trigger that every time the jump key is pressed. Let's test. And there you go. The next thing we want to do with audio is create some sounds for our particle effects. Of all the things that can really benefit from sound, of course, these are pretty much at the top of the list. So once again, let's create a new trigger. And these are going to be specific to the effect. So since we're randomizing our particle effects, we want to make sure that the sound is actually attached to the particle effect in the database. So I'm going to preface these with something that tells me it's intended for use with a particle effect. And as an example, I'll create one for the lingering monitor electric, this sort of computer monitor shorting out sound, or particle effect rather. Something like that. And I've provided a whole bunch of sounds for you, but this electrical one seems to go with that particular particle effect pretty well. I want to make it pretty prominent. It's not that loud a sound. I don't need to attenuate or pan it. I'm going to save my library, and I'm going to come back to my particle database. Make sure that you have your explosions XML open. I'm going to open the monitor folder. I'm going to open my A lingering effect. And I want to add a new item, so I click on this button. I'm adding a particular component to the monitor lingering electric group, and I'm just going to call it audio. You should use a consistent naming system for this. And if I click on this and go to the audio section here, and there are many, so this is a good time to make this window quite big. I'm going to browse for the start trigger, which is going to be my monitor sound that I just made. I don't need to worry about stopping it, but I do need to make sure that this is not 0 and this is set to emitter lifetime. Otherwise, the particle effect is going to spam the engine with signals. I'm going to go ahead and save my particle database. Since I'm randomizing these, it could be a long wait before I find the particular one that I'm looking for. So I'm simply going to select one of my particle effects, and I'm going to go ahead and assign this particular particle effect to it right now. And then to hear it, I'm just going to right-click on the effect in the Level Explorer, go to Events, and Spawn. And there's our sound. So you can follow this same procedure for any other particle effects that you're using in your level. And that's it for Flappy Chapter 11, Audio.